I'm Dr. Amitav Saraswati. Today I'm here with you. We'll be doing lines and angles. When we talk about lines, you need at least 2 points to get a line drawn. For example, if you have a point, through this point you can have infinitely many lines drawn. But to get a unique line, you need at least 2 points through which you can draw a unique line. We'll be studying some of the properties of the angles formed by the lines. What are the different types of angles? We'll be studying them one by one. When a line intersects two different lines, or when a line intersects another line, what happens? So let us study them in detail now. The first is you have an angle formed when two lines intersect or two rays intersect, you get an angle formed. Now this angle changes. The angle becomes an acute angle when the angle is less than 90 degrees. It becomes a right angle when it's exactly 90 degrees. When the angle becomes more than 90 degrees, it's called an obtuse angle. If it becomes more than 180 degrees, it's called a reflex angle. So this is how angles are known as. Segments. What is a segment? When we have 2 points and the line joins these 2 points, we call this to be a segment. Like F and G are two fixed points, and the line segment joining between the two is called the segment FG. Here is an example of a ray. A ray extends to infinity in one direction. That is shown by this arrowhead. So HI is a ray. It starts from this point H and extends to infinity in one direction. Then we have the concept of non-collinear and collinear points. Just imagine or just consider these points J, K and L. These 3 points are non-collinear because they are not in a straight line, whereas the points M, O and N, they are in a straight line. So they are called collinear points. When 3 points lie in a straight line, they are called collinear points, and if they do not lie in a straight line, they are called non-collinear points. Next we have the concept of different types of angles formed. Here we have two lines intersecting. Here is a line intersecting and another line here. When these two lines intersect, then these two angles, these are known as vertically opposite angles, and they are always equal. If we have to check it out, we can change this angle. You will find that the angle on top and the angle below, they remain exactly equal. So these are called vertically opposite angles. Next we have adjacent angles. This angle and this angle are adjacent angles. Incidentally, these two angles are also known as supplementary angles because their sum, that is sum of this angle, which is 73.01 degrees and 106.99 degrees, if you add them up, it comes out to be 180 degrees. So when the sum of these two angles become 180 degrees, they form supplementary angles, and they are also forming a linear pair. Then we have two angles whose sum is 90 degrees. We have one angle here, which is 49.32 degrees, another angle here, 40.68 degrees. If you add them up, it adds up to 90 degrees. So even if these angles change, their sum remains 90 degrees. So they form what are known as complementary angles. The next definition is for exterior angles and interior angles. We have two lines intersected by a third line, which is known as a transversal. When this transversal intersects these two lines, we have two angles formed in the exterior part, that is the green and the pink. They form what are known as exterior angles, whereas these two angles that is light brown and the light blue, they form what are known as the interior angles. So these are the two interior angles, whereas these two and these two, they form the exterior angles. This angle and this angle, they form what are known as corresponding angles. And similarly, this angle and this angle, these two are known as alternate angles. So here you will find that when two lines are parallel, this angle and this angle, which are corresponding angles, they become equal. Similarly, this angle and this angle, they are alternate angles, they are also equal. You will find for parallel lines, always the alternate angles are equal and the corresponding angles are also equal. So even if we drag this line, you will find the alternate angles remain same, the corresponding angles remain same. And then we move on to angle sum property of a triangle. As you know, in any triangle, there are three angles. That's why we call it a triangle. But the sum of the three angles of the triangle always adds up to 180 degrees. How do we show that? We have an applet here. Look at this applet here. We have a triangle A, B, and C. In this triangle ABC, angle A is orange colored, angle B is colored pink, and angle C is colored blue. The sum of the three angles always adds up to 180 degrees. We can prove it here. Visually, you can see why do these angles always add up to 180 degrees. If I drag this, you will find the three angles change to form a 180 degrees here, a straight angle. All the three angles add up and form a straight angle. That's angle A, angle B, and already angle C is here. This can also be proved by drawing a line through one of the vertices. Suppose you are given a triangle ABC here. Through this point, if you draw a line parallel to this side, you will find that this angle is always equal to this angle because they are alternate angles. Similarly, this angle is equal to this angle. They are alternate angles. If I drag this point, you will find these alternate angles remain equal. Hence, the sum of the three angles always add up to 180 degrees. So that sums up the concept of supplementary angles, the angle sum property, vertically opposite angles, collinear points, non-collinear points, line segments, rays, and so on and so forth. So with that, we have come to the end of this chapter. We will move on to the next chapter in the next episode.